Exponents and Logs by Cameron and Lydia. What do the variables represent? The basic equation is y equals abx, a being the initial amount and b being the rate of exponential growth or decay, and x being the amount of years that the growth or decay is given. How do you determine b if given a growth or decay rate? 1. B has to be greater than 0 and not equal to 1. The rate of change increases or decreases across the graphs. Basically, if A is greater than 0 and B is in between 0 and 1, the graph decreases. But if A is greater than 0 and B is greater than 1, the graph increases. As given the example shown below, y equals a times b x, and plugging in the variables 100 and 0.5. This would be an example of decreasing of exponential decay. And the one shown farther below is exponential growth. These will be the basic graphing of parent functions. And this would be the main way to graph a function. How define an equation from a graph? Y equals abx exponential of 2, 2, and 3, 4. Given the equation over here, we would have a times b e to the second power. We would replace y with 2 from the coordinates 2 and 2. So we solve for a using the 2 points from 3 and 4. We would come out with this equation, and will equal out to this. And dividing 2b to the third power over b to the second power equals 2b. But then you have to divide 2 from 2b and 4 in order to get b for 2. And you'd have to plug in your new b into the old equation, and that would get us 1/2. The 3 laws of the logs. First law, addition is equal to multiplication. If we have 2 logs, log A and log B, and we have them in an addition equation, they would come out to be log A times B. But the thing about that is that both logs have to have the same base, as do all of the other rules. The second law is that the exponent has to go at the beginning of the log. Simple enough. And the final law, the third law, is that subtraction is equal to division. Same general gimmick with the first law. When you have 2 logs in a subtraction equation, it comes out to a division equation. And like the other 2 rules, they all have to have the exact same base. Now, how to solve an exponential equation? Well, basically, how to solve an exponential equation is given as y. A simple equation is y equals b x, x being the exponent and b being the base. So plugging in the variables 2 and 3, 2 being the base and 3 being the exponent, we come out with 2 to the third power equals 8. The most efficient way I found for this is to pretty much break everything down into a multiplication equation. The exponent being the number of 2's you would have to multiply. So we come out with 3 2's. Then we multiply 2 times 2 times 2, 2 times 2 being 4, and times 2 again equaling 8. Solving a logarithm is basically you already have the answer for the exponential equation. You just need to find the way to plug it into the log. Plug it into the equation for the log. The basic equation for the log would be log base solution. Then you would have to find the exponent. So let's say it like this: log base 2 of 8 equals 3. The same general way you would try to find the answer to that exponential equation would fit here too. Just keep multiplying 2 until you get 8, then you count the number of 2's you would use. Same general gimmick. And that's it with the all 6 of the M&Ms. So thanks. Bye-bye.